Yeah, hello everyone. Today we will again look at yet another article. The article that is compiled is titled as Brushless Motors in Drones. A brushless DC electric motor, or BLDC it is generally called, is also known as the electronically commutated motor, or ECM. Okay, it is also a synchronous DC motor with direct current. Okay, it uses an electronic controller to switch the DC currents to the motor windings and produces the magnetic fields which effectively rotate in space and with which the permanent magnet rotor also follows. Actually, there is something called as a brush commutated DC motor, and a brushless DC motor. And for the students' purpose, it is required that we know the difference between these. There is a picture which shows here that how a brushed commutated DC motor looks like, and how this brushless is there. Here in the brushless, actually the copper coil windings etc. Are on the stator, and the permanent magnet is bonded to the rotor, and it generates the magnetic flux between the rotor and the stator. The air gap is much closer. Okay, so this is a better motor for drones, basically because they have much longer lifespan since they don't have brushes, and that can wear it down. Brushless motors are most powerful for their size, because they are more lightweight, and for the size that they are chosen. Generally, the brushless motors are categorized by a 4-digit number. Example, like a motor which is named as 2205. The first two digits represent the diameter of the stator, and the last two digits represent the height of the motor. Okay, the wider and the taller, etc. There. Okay, now. Theoretically, the brushless motors kV ratings represent the speed at which the motor rotates for every volt applied to the motor. For example, if a motor is 2300 kV and with a 3S quadcopter battery motor applied to its ends, then the motor will spin at 2600 into 12 into 12.60, that is equal to 32,760 RPM. Okay, so the RPM decreases gradually because of the air resistance. The motor kV represents the speed at which the motor rotates for every volt applied to the motor, and the higher the kV means lower the resistance and higher the current drawn and lower the efficiencies. Okay, so lower kV means higher resistance and lower current drawn, and considerable better efficiencies will happen. So you will have to trade off between the efficiencies. The new motor nowadays are used are sometimes hollow shafts because they want to reduce the weight of the motor. This has its own positives and negatives. Hollow shafts obviously reduce the weight of the motor, but they are less durable and during the crash time. Okay, so this article has tried to cover the basics of aspects of brushless motor. For further reading, definitely we may have to go through the references that has been mentioned in the article. This article, however, the for the performance factors, one must consider the kV, or the velocity constant, torque, efficiency, temperature, and the current drawn. There are other factors to this, are the N and P numbers, single or multi-stranded wires, whether it is regarding the motors, regarding the motor windings, the motor weight, and its mounting patterns. All these are to be considered. The following are the features to look in for in a motor, like its shaft, its air gap, the motor wires, retainer wires. Okay, whether it is a clockwise or counterclockwise rotations, and whether it is an open or closed bottom motor. Right. So with this, we will conclude on the brushless motors. It is a compilation of trying to bring out the understanding of how a brushless motor works. So with this, I will stop, and I will meet you again on a another